Hey, this is Jody with weldingtipsandtricks.com. I know you're busy, so let's get right to it. Alright, first of all, I got the idea for this video on my welding forum. It's at theweldingforum.com. Great bunch of guys, a whole lot of knowledge. Question came up about macro etch testing for welds. So here we go. Today we're going to be doing something called a macro etch test. And we're going to cut, polish, and etch this downhill weld and this vertical uphill weld that was done at exactly the same settings as the downhill weld. And then also there's a lap joint right here that's got a TIG weld on one side just using ER70S filler rod, and then the other side has aluminum bronze TIG braze on it. That should be interesting to see the difference there. And then just this random piece of aluminum with a lot of different weld beads on it, just to talk about what to use to etch aluminum with. The same chemical solutions will not etch just any material. It takes different solutions for different materials. So for instance, carbon steel typically will etch very well using a nitric acid blend. However, this video we're talking about using over-the-counter stuff you can get at a hardware store and even the grocery store. Now, there's lots of different kinds of testing. Remember a good while back, I welded a bicycle frame on the strong hand table, and then I took it outside and did the BFH test on it. And also, I was doing a repair on a forklift and I wanted some confidence that my settings were good, so I welded this little similar setup with the similar thicknesses and everything, and just hit on it with a hammer and try to break it and prove to myself that it was not a cold weld and that it actually was like it appeared to be going in there while I was welding it. Just another little piece of information. It's not a conclusive test, not a scientific test, although a fillet weld break test is a legitimate test for certain applications. Alright, to start with, I'm going to weld this T-joint downhill using some pretty cold settings. About 200 to 210 inches a minute of 035 ER70S6 wire. And I'm kind of hanging back in the puddle a little bit, and I'm trying to make kind of a cold weld actually, just to prove a point difference between downhill and an uphill weld. A lot of discussion on welding downhill with MIG. It can easily get lack of fusion. I have seen welds like this just pop loose with one good blow of a hammer. And so I'm going to mark it, and I'm going to cut a cross section right there, and we'll polish and etch and visually examine it. But first I'm going to weld the same joint, same settings, same wire feed speed settings and everything, just weld it uphill using a technique where I try to trace the leading edge of the puddle. Now the cup had the arc hidden right there, so I'll give you another look at it here. But basically I'm trying to come straight across and then trace the front of the puddle in a series of triangles. Sometimes it looks like I'm doing an upside down V, and I may be actually with the camera in my way, but I took kind of big steps. That's why it kind of looks a little scalloped there, but we're going to cut it and polish it and etch it anyway, see what it looks like, and that's where we'll cut it. So I'm just doing all this cutting here with a little portaband stand that I made a while back, and it's taking a little while, so I'm speeding everything up here quite a bit. All right, first up here, let's sand and polish this vertical uphill T. A saw is a good way to cut it. Actually, the best way is probably on a horizontal bandsaw, or maybe even something that gives you a finer finish than that. But the finer the finish you get cutting it, the less sanding and polishing you have to do. And I'm starting out here with a 180 grit, and I'm going to get all the saw scratches out of it with this disc. So all I'm going to see is the swirl marks from the sanding disc. And I'm not going to stop until that's done. And then I'm going to gradually use finer and finer discs and get a decent polish on this thing. It's not going to be a mirror polish by any stretch, but just using about 3 different steps, we'll get something adequate for a macro etch test. And a macro etch is usually just viewed either with the naked eye or maybe at the most 20x under a stereo microscope or something like that. So it doesn't require the kind of polish that you use for microscopic examination. So I'm using a Scotch-Brite pad here, the burgundy colored one. And then I will step it down to the blue-green one, and I'm going crossways each time. I'm changing my direction of my scratches so that I'll know when I got the previous scratches out. That's good practice. Not 100% necessary, just good practice. This little Rolock disc set that I'm using here, actually I picked up at Harbor Freight a couple weeks ago when I went on my annual shopping spree there, and I kind kind of had my doubts about it because sometimes you buy things like this and you're like, what can go wrong? And then it's all out of balance and wobbly and hardly works, but it's working really well. Score. All right, I'm going to etch this with Naval Jelly, Loctite Naval Jelly Rust Remover. This shows that it contains phosphoric acid. There's another product out there called Osfo Rust Remover that's supposed to work just about as well, or maybe even better, but this works pretty well. As long as you take your time, get a decent polish, and put a little heat on it with a heat gun or a little small propane torch or something like that. Just warm it up to maybe 100, 150 degrees. Just a little bit of heat on it activates the chemical in there and makes it kind of work a little bit better and a little bit faster. So I'm going to give it a little quick rinse off here. Now this is a temporary thing here. If I wanted to really, save these or archive them, I might put some kind of clear coat on them or something, but because they will rust after this. But I just want to get a look at what I did while I was welding, and now I see. The weld nugget looks a little irregular, but it's in there. It punched into all the way to the root of the joint. Got some pretty decent depth of penetration. Right there on the toes where I paused, it penetrated a little bit deeper. That's typical when you're tracing the puddle like a three-point technique where you're going into the root of the joint and then bouncing from side to side. So, at those low settings, not too bad. All right, now let's look at the downhill. We see problems there already before we even get an etch on it. There's lack of fusion right in the root of the joint. It didn't make it into the root of the joint. And as we etch further and further, we see that it almost looks like a braze joint. Really no depth of penetration at all, barely bonded in some areas. It got a little bit past the surface here and there. It looks like a braze joint, honestly. Speaking of braze joints, we're going to do one here. There's an aluminum bronze joint on the right that was TIG welded using alternating current, and on the other side is a lap weld at about 140 amps using an ER70 rod. Before we look at the polished and etched results, here's the arc shot of that joint being done in a previous video. I'm motoring out pretty good at 140 amps. And now here's a quick arc shot of the lap joint done using aluminum bronze on alternating current, where I'm just kind of washing that metal forward. The cleaning action cleans up the puddle, and it is a TIG braze joint. Not welding, brazing. There is some welding going on. It definitely occasionally melts the metal. But it makes for a nice looking bead, and it's something that a lot of artists would want to do for metal art and things like that. Alright, now there's the cross section of the aluminum bronze TIG braze joint. You see it basically looks like a braze joint. No depth of fusion at all. It flowed in there. It's at right angles. Unlike the ER70 weld joint here that has a nice weld nugget profile where it penetrated, melted the corner off a little bit because it's a weld, and the other one is a braze. All right, let's take a peek at the aluminum thing here now. I'm going to shoot some easy off oven cleaner on here, and I've already kind of heated it up a little bit, and I'm going to blow the heat gun on there a little bit more to accelerate the action. And this takes several minutes, but you can see here after it's done, the weld beads are revealed pretty well. You can tell what's weld and what's not. And that's, again, easy off oven cleaner with just a little extra heat and a little bit of swabbing with the Q-tip to kind of accelerate things. Those are some down and dirty cut, polish, and etch techniques. Not the textbook way, not ASTM standards or anything like that. Just a down and dirty way to immediately check a weld while the puddle is still fresh in your mind's eye. It's a good training tool. You weld something and you're seeing what's going on and you're thinking, okay, I'm definitely cutting into that leading edge of the puddle, or maybe I'm not quite cutting in there like I think I should, and then immediately cool it off, cut it, polish, etch. Minutes later, while the image of the puddle is still fresh in your mind, you see the result and you can make adjustments accordingly. So the macro etch test, really valuable learning tool. And once again, off the shelf, over the counter stuff. Naval Jelly's got phosphoric acid in it. That will etch carbon steel, especially if you add a little heat to it with a heat gun. It speeds the etching process up. The finer the polish you get, the better the etch is going to react, and the quicker it will work, and the more definition you'll have or delineation between weld metal and base metal. Now, side note here, the reason that this works is because weld metal is different than the base metal typically. The weld metal is a cast microstructure because it's molten and then it's solidifying. The base metal usually is a wrought material. If you're doing bar stock or extrusions or anything, it's going to have the grains elongated in it, so that it responds to etch differently, and that's why you can see the weld so clearly as opposed to the base metal. That's the whole premise behind the thing. For aluminum etching, easy off oven cleaner, it works pretty good. And sodium hydroxide is in this, and that's what does it's a high pH alkaline cleaner, and that really does a job on aluminum. All right, well, that's it. See you next week. And one more thing, be safe. Even though this is over-the-counter stuff that you can get in hardware stores and grocery stores, there's always hazards involved. So follow the instructions, make sure to wear gloves and eye protection, and all that good stuff. All right.